Okay guys, 2.6. We're talking a lot about transformations today, and you guys actually know a lot already. So here's what I want you to do. Go ahead and use this bracket, and that's going to be our function. So we're going to pretend this is like a function squared. So a quantity squared. So go ahead and, I used to highlight it, but use whatever you want, okay? And then we're going to define each of these things. So usually it's like y equals x squared. So that would be our parent function, y equals x squared. So what does the k mean? You guys know what the k means. That's a plus k. That is a vertical shift going up k. All right, so it's a positive k. So I'm going to show you the other ones, but really you guys, I'm pretty sure you guys know this, okay? So this one especially first. This is a horizontal shift, h, right? So x minus h, x is lie, remember? So really your shift is a positive h, but it's written as here as a minus h. These negatives, this first negative is a reflection over the x-axis. I want you to think about why that would be true. So let me cover all of this up, and you can see y equals negative. What happens when y changes from a positive value to a negative value? So think about on an xy, when y is positive versus when y is negative, oh, it goes over the x-axis, right? Positive y, negative y, it goes over the x-axis. That's how you can remember that. All right. When the negative is belonging to the function, this is a squared function. When the negative is inside of that squared function, belongs to the x value basically, it reflects over the y-axis. Why would that be true? Well, that's true because if something belongs to the x, what happens when you have an xy and you have a positive x versus a negative x? Positive on the right side, negative on the left side for x's. Oh, you're going over the y-axis. So that's why it's a reflection over the y-axis. Okay, what does that a mean right there? Well, first I have to decide, does it belong to the y or does it belong to the x? Only this belongs to the x. This right here belongs to the y, right? Y equals negative a. So a belongs to the y. So a belongs to the y. B belongs to the x, and x is lie. So this is your vertical stretch if a is bigger than 1. It's a compression if a is a fraction or a decimal, something between 0 and 1. Right? If a is 0, that just messes with everything. So we don't want a to be 0. But if a is between 0 and 1, then we have a fraction or a decimal. And then we have like a function that compresses vertically. So when I say compresses vertically, you take it and then you smush it vertically. So that's compressing vertically, okay? So this is the key. So this is why it's highlighted. So b belongs to the x, right? It's inside the function squared. So if b belongs to the x and x's are liars, right? My ex, man, he's such a liar. He always lies about me. So x's are liars. B is a stretch if b is a fraction. Because when we take it out, when we take the fraction out, what actually do we do with that value? We actually flip it and then multiply by it. So that's why it's a stretch if it's a fraction. Because when we take it out, we flip it. And then it's a compression if it's a big number. Like if it's a 2, it's actually a compression of 1/2. So if this is a 2, that would be a horizontal compression of 1/2. Because b is 2, and when we take it out, it really gets multiplied by 1/2. Okay? Okay, so explain each transformation. All right, so what is this? So you're filling that in. So the first thing is, what kind of parent function is this? Well, we can tell it's a square root. So it's a square root function. We want to know generally what it looks like. And then I want you to do a little picture of it. So a little picture of this. Well, actually not yet. When we're graphing, I want you to do a little picture of it, which would be like that, and then to the right. Okay? So when we're graphing, definitely do that part. Okay. So then what's the first thing that happens? Well, the first thing that happens, let me see if I can go slow. The first thing that happens is there's a negative in front. Well, what does that mean? That means there's a reflection over the x-axis. I want you to write this. I don't want you to be lazy. I don't want you to just write this part. I don't want you to just write this part. I want you to write reflect over x-axis. You can write ref, and then you can write x-axis. How about that? But then you have to write, oh, that gives me a negative y. So I want you to tell me what happens and what's the result, okay? What's the second thing that happens? So it has to be in order, kind of like how this is in order. I want it to be in order, and then you start from left to right. So the negative is first, and then the +2. What does that tell me to do? Oh, that's a horizontal shift. And the horizontal shift, if you want, you can write HS. The horizontal shift is x is y. So left 2. You can also write x minus 2. So either those are okay. I actually like this one better, I'll be honest with you. Okay, what's the -1 at the end? That's a vertical shift, down 1. I actually like y minus 1 a little bit better. So I would rather you write it like that. Okay, so just, I mean, I know these are my notes, but I would rather you write it like that. Okay, okay. And then, how about this? This is a square function. I want you to realize this is a square function. That's the parent function. And in general, it looks like this, right? It's a parabolic. It's a parabola. Okay. So what happens first? What is that 1/2? That is a vertical. Ooh, that belongs to the y. That is a vertical. Oh, I rewrote it. Sorry. So because it has a negative in front of the x without a parentheses, I had to make sure it looked like this, right? So I want the x all by itself, and then I want an x minus or an x plus all by itself. So it didn't look like that, so I had to fix it before I could keep going. Okay, now what does the 1/2 look like? Let's see. The 1/2 is going to be a vertical compression of 1/2 y, and then the negative is a reflection over the y-axis. And then what's after that? The x minus 3, oh, that's a horizontal shift. Whoops. Horizontal shift to the right 3. And then, again, I would rather you do x plus 3. That's even better than right 3. Okay? I don't love right 3 all the time. But that's true, and that's also true. This one's better, though. Because it tells you exactly what to do. We're going to use that a lot more later. Okay? Okay, C. So, is there anything I need to change to make it look like this? Yes, I need to factor out the -3. So factor out the -3, and then you get that. Don't always copy me. You're doing this on your own, right? You're like pausing and doing it on your own. Okay, so now how many things do we have to write down, right? I wrote down 3 here. I wrote down 3 here. Let's see. 1, 2, 3, 4, 5. There's 5 steps for this one, okay? I want to see all 5. I don't want you to combine. Okay. So the first thing is, what kind of function is it? Did I write? Did I write? I didn't write. Let's write that. So this is a square root function, which is a y equals... No, that's not a square root function. Jeez, I'm sorry. Fast forward through this, guys. This is an absolute value function, and that looks like y equals absolute value of x, and then that generally looks like a v. So I do want you to like know this, you know, as you're doing it. Okay. And then what is the first step? Okay, well that 2. What's the 2? It's a... So I think you should do this on your own. Pause it and do it on your own, and then check your answers. How about that? So do all 5. Okay, so here are the answers. So here's all 5. So it's a vertical stretch. See? It's a reflection over the y-axis. Tell me what happens. It's a horizontal compression. The 3 belongs to the x's. It's inside the absolute value function. If it's inside those bars, then it must belong to the x. Okay, so it's a compression. Be careful. The horizontal is to the left 2. I like x minus 2 even better. And then the vertical stretch or vertical shift is y plus 1. Okay, so I like that part even better, like that. Okay, so in the next question, we're starting to write it the other way. So if we write it the other way, start from the absolute value function and do these things. Whoops, sorry. and do these things 1 through 4. So we're going to start with an absolute value function. All right, pause it if you need to. We're going to start with an absolute value function. So I start with that. And then I number it. Number 1, what do I do? To the right 2, what does that look like based on this parent function? I go ahead and do that step. Number 2, a horizontal compression of 1/4. What does that look like? Can I just put a 1/4 in front? I don't think so. It's like that, right? So really, it belongs to the horizontal, so it's a big liar, so it's a 4 when it's in there. Okay. And then what does the reflection over the x-axis look like? The negative goes in the very front. And then number 4, vertical shift down. Okay, that one's kind of easy, so -5 at the end. Okay? Okay, so the graphing is the most important part. Like, all of this is to get to the graphing. Let's be honest, okay? All right, I'm going to show you, but this has to be like done in steps, so I'm going to explain it in steps, okay? So let's say you have something like that. So a -3 over x minus 2 and then +1. I want you to write the parent function. I want you to draw the parent function. Yes, I expect you to memorize that. You have your notes. You will run out of time, guaranteed 100% if you don't remember what these things look like, okay? So remember what they look like by now. So that was 2.5. All right, so the first thing I'm going to do after I draw a little picture for myself is let's make sure it's in the right format. If this is what it looks like, then let's make it look like that. Let's pull the -3 forward so that we can really see it the way that we saw it, the page before. Okay, so then what is number 1, 2, 3, and 4? You write them. Don't just copy me. And then you check them. So those are the 4 steps in that order. Does it have to be in order? Absolutely, it has to be in order. I'm going to write x plus 2. I'm going to write y plus 1. That's even better, okay? Okay, so you have these 4 things. It has to be in this order. You don't have little checks yet, okay? Here's why I put the checks, all right? So what I'm going to do first is I'm actually going to do it on this paper, and then I'll show you in my notes. But what I'm going to do first is I'm going to do an XY, and I'm going to do it right underneath here, okay, an XY, and then I'm going to do my normal -2 all the way to +2, and then I plug it into my parent function. My parent function, I plug it in, I get -0.5, -1, nothing, right, because you can't have a 0 on the bottom. I have a 1, and then I have a +1/2. Okay, and then this is where the check marks come from. So the first thing I have to do is I have to change all my y's to negative. Ready? Here we go. Plus, plus, minus, minus. Check. I'm done with number 1. And then I'm going to do number 2, a vertical stretch of 3y. I take all my y values and I times 3. So 3 over 2, 3, still nothing, -3 and -3 over 2. I'm going to cross these out because I don't like looking at them. Check, done with number 2. Number 3. Okay, now I look at my x values, and this is why this is so helpful. I add 2 to all my x values. So +2, +2, +2, cross, 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 cross. Don't be a maniac and cross them all out like a monster, okay? Because then I won't be able to see your work. If you make a mistake, if I can see your work, you get more points. But if you cross it out like a monster and I can't tell what you did, you get no points. If you don't do this at all, you get no points, okay? So you have to do it this way. So we're learning about transformations. We're learning how to do it a certain way, okay? So that's step 3. Step 4, you're going vertical shift up 1. Okay, so I take my y values and I plus 1. So this is 1.5, it's going to turn into 2.5. And then plus 1 still gives me nothing. So nothing. And then plus 1, and this is -1.5, so it's negative like 0.5. Cross, 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 cross. Okay. So now I take these and I have these x values which go with these y values, and I plot these points. So I plot 0, 2.5, 1, 4, 2, nothing, which means that at 2, 1, 2, I have my vertical asymptote. Okay? And then I plot the rest. And after I plot the rest, what I realize is, so I did it right here, okay? So after I plot the rest, what I realize is I have this vertical asymptote, and my graph is supposed to also, I look at my original, it's supposed to also have a horizontal. Where would that horizontal be? Oh, it's right here. It got shifted positive 2. So instead of 0, it's now, well, instead of 0, it was positive 2. And then right here, this got shifted up 1. So my horizontal asymptote got shifted up 1 because everything got shifted up 1. So you can see my 2, 1 is my new center of my graph, right? Because that was the shift of the graph. And then everything should be nice and symmetrical. It should look like this, but it's flipped, which makes sense. There's a negative, and then there's a shift. There you go. So there's number 3. That's the order in which we do it, okay? Okay, so number 4. Let's give this a try. Number 4, you have this as your original function. And then you can see what kind of function is this. It's an absolute value. So my parent function is a y equals, and then that looks like a v. So in the end, I have to check that my answer looks like a v. It could be upside down, it could be fat or skinny, but it looks like a v. Okay, is there anything I have to do to change this? I don't think so. So there are 1, 2, 3, 4, 5 things that need to happen. So 1, 2, 3, 4, 5, you list them. Don't just copy me. And then hopefully you listed these 5 things. Okay. So the last 2, again, I'm going to do an x minus 1 and a y minus 4 instead. Okay? Okay. So this is how, on the bottom, I would do my xy. So underneath, I would do an xy. And then I would start from -2, -1, 0, 1, 2. And then I plug it into my parent function. My parent function is absolute values. So I just make them all positive. There you go. Okay. Now I'm going to do step 1. And it says reflect. I don't have to read this part anymore. I can just do what I told myself to do at the end. So change all the y's to minus. Negative, 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 negative. You can put a negative here, but it doesn't matter, right? Okay, step 2. Now multiply the y's by 2. So -4, -2, 0, -2, -4, cross, 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 cross. All right. And then I put a check, right? So check, check. Okay, horizontal stretch of 3x. Okay, now I have to multiply my x's by 3. So -6, -3, 0, 3, 6. Cross, 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 cross. And then left 1. So I have to do it in this order from left to right, and I have to do it in this order, okay? Otherwise my answer will be wrong. I guarantee it. Okay, so x minus 1. -7, -4, -1, 2, and 5. So I subtracted 1 from each number. And then y minus 4. Okay, -8. So -4 from each one. That was all my steps. So I have these x values that go with these y values. My points are -7, -8, -4, -6, and so on. And then I graph them. And then I see a V shape, and then I fill in that V shape, okay? If you're 1 unit off, it's fine. But if you were more than 1 unit off, that would be no good. You'd have to condense your graph, so you'd have to go by 2s. If you're more than 1 unit off, like if this actually started like down here or up here, maybe just right here, and then this whole shifted down a little bit, I would need to go by 2s. I would have to do like 2, 4, 6, 2, 4, 6, okay? You can just put a little 2 and a little 2 when you're going by 2s. Sometimes that will need to happen. Okay. Obviously you need graph paper, yes. So I posted the homework and everything, but you need the graph paper. And then I would suggest you use my graph paper, but you don't have to. You can do whatever you want, okay? You can use your own graph paper. That's fine. All right. Good luck.